Hello, everyone. Thank you for coming to hear my session about embracing error handling with Kotlin Result library. My name is Omrit Zemach. I'm a squad leader at Sunbit. I joined Sunbit 3 years ago. Before, I worked on several companies. And today we are going to talk about a topic that is relevant to every developer. We are going to talk about error handling, but we are going to look at a different and unique way for handling errors utilizing the Kotlin Result library. Please raise your hand if you are not familiar with Kotlin as a programming language. Okay, don't worry, because this session is also relevant to you. Because today I'm also going to present a concept. And this concept is used and implemented also in other programming languages. So this can be beneficial to you, especially if you want to handle errors in a functional way. So stay tuned and let's get started. So I would like to start with a story that I think you can relate to. This is the coffee machine in my office. So I don't know what about you, but I'm a kind of person who have to take his coffee in the morning. So the first thing I'm doing when I'm arriving to the office is go straight to the kitchen to make the coffee. The problem is that sometimes I am greeted with this unclear error message blaring from the screen. Error, please check machine. There are no guidance, no explanation, and I need to figure out what happened to the machine. The coffee machine example is a minor inconvenience for me, but similar issues can also happen in the software we create. And there, it can be more than just inconvenience. It can lead to real frustrations of the customers and users. So as I mentioned, I'm working at Sunbit. And at Sunbit, we help people to pay over time their unexpected expenses, mainly in essential services like dental care, auto repair, eyewear, and more. And the process is very simple and quick. So let's say I'm a customer that is coming to the dentist. If I'm unable to pay the amount required, the representative in the store offers me Sunbit as a payment solution. So I insert my details to Sunbit software, and in a quick process, we scan the credit history of the customer, and we calculate the risk using AI and machine learning. But the question is, what happens if things don't go as expected? If, for example, a returning customer didn't insert his details as they are saved in our database. Here, unclear error message can be more than just annoyance. It can lead to real frustrations of the user who hope to get finance solution to his essential care. It can also destroy the trust in our product. So today, I'm going to share with you the journey we undertook at Sunbit. From discovering the challenges in traditional error handling, through searching for viable solutions for these challenges, and finally, discovering the Kotlin Result library as the ultimate solution for these challenges. So the first and most critical challenge is that in Kotlin, all exceptions are unchecked. But also in Java, we have the concept of unchecked exception. What it basically means that the compiler doesn't force us to handle exception in case we are calling to a function that throws one. It also doesn't require from us to declare on the function signature that it's throwing an exception. So developer may not be aware of the potential exception that can happen at runtime. So if, for example, we will look on the register purchase function that is called when a customer is starting a purchase transaction with our services, so this function is calling to the create or update customer. If we will look on the create or update customer, according to his signature, it looks secure and safe, right? But if I go inside the implementation, I will discover that in some cases that the customer is a returning customer and his details are different from the one in our database, we are throwing an exception. As a developer, I may not be aware of this potential exception, and this can eventually be propagated to the end user with a general error, and he may think that the product is not working. So you can say, look at the implementation of the function. But most of the cases, the exception is coming from a deeper layer of the call stack, and it is invisible for us. The second challenge that is also related to the previous one is that even if I am aware that a specific function throwing an exception, in order to recover from this specific exception, I need to know to which exact exception to look for and to catch. In a small service, this may be an easy task, right? But in a service that's maintained by many teams, this can be a real challenge. The third challenge is that we need to propagate error through different application layers with a meaning and a context. So we would like to translate third-party exceptions to internal exceptions and to remove dependencies from third-party libraries. We'll also want to translate some technical exceptions, which don't mean anything to other service, to internal exceptions in the context of our service. And at last, we would like to translate this exception to an HTTP response with an appropriate error code and status. So in order to do that, we will need to try catch every exception type and to map it to a different type. This will cause our code to be more complex and not clean. So if I need to summarize the different challenges, so the first and most critical one is that when we are talking about unchecked exceptions, developers may not be aware of the potential exception that can happen at runtime. In order to be aware of the different exceptions, they need to have an in-depth knowledge of the different exceptions in the service. Most of the cases, this is a real challenge, and therefore, function execution are unsafe. Last but not least, try-catch make our code very complex and not clean, and certainly not functional. So we thought about a possible solution, and a possible solution will be to create a kind of response wrapper that encapsulate both the data success type, but also the throwable object. And if one is initialized, the other is not initialized. So instead of throwing an exception, we can return the throwable object also as an output of the function. Let's see how we can use this response wrapper. So in the create or update customer, when we have discrepancies in the customer details, now instead of throwing an exception, we will return the customer validation error in the response object using the failure constructor. In other case, in success case, we will return the output success of the function using the success constructor. So what we gain here? First, we gain observability. Now it is clear in the function signature that this function can also return customer error, and the developer needs to consider that. Also now this function is secure and safe because we are not throwing an exception that can be exploited at runtime, we return it as an output of the function. But the problem is that solution is that in order to understand if the response in the calling function, if the response encapsulates success or error, we have to open the response object and to check. If it has success value, we will need to unwrap it from the function and to apply to the next function, and again check if we have success or an error. So this will lead us to an endless if-else statements and to some kind of callback hell. And it's really hard to understand the main flow of this function, right? So this is not a possible solution. And the question is, can we improve it? So let's return to the coffee machine example. And let's imagine it as a really small program with two functions. The first, get coffee beans, return us the coffee beans as success value, or can throw exception that telling us that there are missing coffee beans. The second function, the make coffee, takes the coffee bean success value and returns our desirable coffee or an error telling us that the water tank is empty. So the first thing we would like to do is to encapsulate the success and error value in the wrapper. And now the got coffee beans and make coffee returns, both of them returns response with either success or an error message telling us what happened to the coffee machine. And think of this wrapper as a kind of mysterious box that until you open it, you don't know what there is inside. So one option is to open the box and to check if we have an error inside or a success. But we already saw that this leads us to a complex path, and this is not a possible solution. So what we actually need is more than just a wrapper. We need some kind of bind function that will take the wrapper that encapsulates either success or an error as an input, and in case of success, will apply to the next operation that also return a wrapper with a success or an error. And this bind function will hide all the complexity of the if-else statement that we saw before. So in case this bind function will get as input a wrapper with an error inside, it will maintain the original input and will return it as the output. So the original error will remain. In case you get a wrapper with a success value, it will unwrap the success value and will apply to the next operation that will return a wrapper with either success or an error. So in the end, if everything goes successfully, we will end up with a wrapper with a success value inside. But if something went wrong, we will get as an output a wrapper with the exact and detailed error message of what happened to the coffee machine. So if we would implement such kind of bind function, we will be able to change the two operations. And you can see now that this code is more clear, clean, and short. So it turns out that the concept of a wrapper that encapsulates a value in a specific context, in our case failure or success, and its bind functions that know how to chain together two operations that return a wrapper, is a known concept that is called monad. It also, by the way, implemented in the optional structures that you're probably familiar with. And it also turns out that we don't need to implement such a bind function ourselves because there is out-of-the-shelf solution of the Kotlin Result library by Michael Bull that already use monad to model success or failure operations. So the result library offers the result monotype, which is very similar to the wrapper we have created before. It encapsulates either the success value or the error, and if one is initialized, the other is not. And it also offers the OK and error constructor to initialize each one of them. And in order to make the explorations of this library more engaging and visualized, I am going to use something called railway-oriented programming, which make an analogy of the result type as two railway tracks. One is a success track, and one is an error track. So we are going to rewrite the register purchase function. So just as a reminder, the register purchase is called when a customer is starting a new purchase transaction with our services. And it is including two functions, the create or update customer and the create purchase entity. And as we saw, both of them can throw exception at runtime that we may not be aware of. So we are going to use the Kotlin Result library to improve the error handling here. And let's see it in the next slide. So one option to use the library is to use explicitly the OK and error constructors. So in the update or create customer, instead of throwing an exception when we have discrepancies in the customer details, we will return a result with the specific error, customer validation error, using the error constructor. In case of success, we will return the output success of the function embedded in the result using the OK constructor. So again, what we gain here is observability of the specific error, and now it's clear that this function can return also a customer error. And we also now, our function is secure and safe. Another option to use the library is wrap your existing code using the run catching of the Michael Bull library. And the run catching wrap your existing code, and under the hood, in case it throw exception, it catch it and return a result with the throwable error inside. Otherwise, in case of success, it returns the success value output of the function in the result. So what we gain here is the run catching by wrapping the existing code, make your function secure and safe. Your function cannot throw an exception at runtime that can explode because it is returning as an output in the result type throwable. It's true that the throwable type is not clear, but we will see later how we can improve it. So we already saw in the coffee machine example that the power of the wrapper is in its bind function. So the Kotlin Result library implements the add function that knows how to chain together two functions that return a wrapper. Let's use the railway analogy to understand how it works. So then gets as an input two railway tracks with either success value or an error value. It also gets as an input a function that takes the success value and return a new result type. And under the hood, what it is doing is, in case of success, it unwraps the success value and return a new result of the next operation. And in case of an error, it bypasses the next operation and propagates the original error, result error, to the other functions. So in the end, we will get a result with either the success output of the next operation or an error that is originated from the original result or from the next operation. Let's use the and then to rewrite the register purchase, and we will use the and then to chain together the create or update purchase and the create purchase entity. We can chain them because both of the functions return result. And how it will work, in case the create or update customer will return a result with success value, it will unwrap the success value, the customer entity, and will apply to the next operation of the create purchase. But in case the create or update customer return a result with the customer error, so it will bypass the next operation and will propagate the error through the chain of operations. But what if we would like to map the throwable type to a more specific error, or to map the success purchase entity to an output DTO? The and then knows how to chain together two operations that return a wrapper. But if we would like to apply simple and to chain simple transformation function, so for that, the Kotlin Result library offers the map and map error functions that knows how to map one type to another. The map error will run its transformation function in case the wrapper holds inside error type. And the map will run its transformation function in case the wrapper holds and contains a success type. Let's again use the railway analogy to understand how it works. So the map gets as an input a result, again with either success or an error, and gets a transformation function that maps one type to another. Under the hood, in case the result has a success value, so the map unwrap it, okay, and run the transformation function on the value, and rewrap it in a new result type. In case of an error, the map maintains the original input and output it as a result. So in the end, we will have a result with either a success value, which is the output of the transformation function, or the error from the original input. The map error is very similar, okay? It has a result with either success or an error, and a transformation function that maps one error type to another. But now, the map error, just in case of an error, runs the transformation function and return a result with the new error type. And in case of success, it maintains the original input. So let's see how we can use the map error and map. And then returns us a result with either purchase entity or throwable. The map error, in case of the result encapsulate the throwable, will run its transformation function and we'll transform it to the corresponding HTTP response. In case of success, the map will get the result with the purchase entity, and we'll run the transformation function that will map the purchase entity to an output DTO. So let's try to simulate how it will work, okay? So we have the register purchase, and let's think of a scenario of success. So in case of success, create or update customer return a result with the customer entity success type. Then we'll unwrap the customer entity and we'll apply to the next operation. The create a purchase, in case of success, will output a result with the purchase entity. The map error, in case it gets a result with a success value, doesn't run its transformation function, and it maintains the original input and return it as an output. So we will remain with result with purchase entity. The map will get this as an input, and in case of success, it runs its transformation function, and we will get an output result with the output purchase DTO. Now let's see how it will work, and the result will be propagated in case of validation error. So in case of the creator update customer as a validation error, we will output a result with the customer validation error. In case of an error, then we'll bypass the next operation and we'll retain the same input it got. So we will end with result with customer validation error. The map error, in case the result as a customer validation error, will run its transformation function and we'll take the customer validation error and map it to the corresponding HTTP response. So we will have a response entity with the status of conflict and an appropriate message. The map, in case it gets a result with an error type inside, doesn't run its transformation function and just remain the same input result. So we will end up with a result with an HTTP response telling our customer that there is a conflict with his existing details. So the Kotlin Result library implement every operation you can think of, from login to recovering. I encourage you to go into the GitHub of the library and to explore more. So if I need to summarize what Kotlin Result giving us in comparing to traditional error handling, so first, as we saw, traditional error handling, exceptions are unchecked, and developer may not be aware of the potential exception that can happen at runtime. In Kotlin Result library, exceptions are explicit in the result type. In traditional error handling, function execution are unsafe when we talk about unchecked exception, because exception can be exploded at runtime. But in Kotlin Result library, if you will use it properly, function execution are safe. Traditional error handling requires from us an in-depth knowledge of the different exceptions, but in Kotlin Result type, the error type is encoded in the result type. And last but not least, traditional error handling make our code very complex with the try-catch, and in Kotlin Result library with the many operations it suggests, our code is more clean and functional. So thank you for listening. This is the reference of the Git Mikeable Kotlin Result library. And if you want to read more about trailer-oriented programming, this is the link. Thank you for listening. And if you have further questions, please reach me out after this session.